Seen any big birds recently? IceCube has. If you think that's a cool name, you're right. IceCube is an observatory at the South Pole, and it saw a big bird back in December 2012.
IceCube is a neutrino telescope located at the South Pole, or to be more precise, under it. It consists of over 5,000 detectors that are spread out into a cube about 1 kilometer on each side. It's the world's biggest and its coolest telescope. IceCube has detected a handful of extremely energetic neutrinos. One of them, which is called Big Bird, has an energy of about 2 peta-electron volts. To give you an idea of how much energy that is, it is about 1 million times the energy of a dental X-ray.
Scientists have been using the names of critters from the popular TV series Sesame Street to designate major events that may help us better understand the particles that emanate from space. Particles like neutrinos.
So a neutrino is an incredibly small particle. It moves almost at the speed of light, is nearly massless, it's incredibly plentiful, but it's very, very hard to detect because it will not interact with just about anything. If you could detect them though, because they have traveled through the universe essentially undeflected, they have information that you could not access in any other way.
The theory is that neutrinos are caused by violent events in space. In 2012, light from such an event began reaching Earth. This was a year-long outburst which happened 10 billion years ago in the unromantically named galaxy PKS B1424-418.
What we have been able to establish for the first time is an individual blazar as a potential birthplace of an individual neutrino. The Fermi Gamma-Ray Space Telescope has an instrument called the Large Area Telescope, which we use to monitor the gamma-ray sky, the highest energy electromagnetic band. And we just noticed that there was a tremendous increase in the amount of gamma-ray light coming from this one extragalactic blazar. A blazar is an extremely powerful, variable galaxy that is powered by a supermassive black hole. It went up not by a little bit, not by a few percent. It went up like 15 to 30 times its average flux. So we knew something was afoot. Later on, it turned out to be coincident both in time and in space with the neutrino that was detected by IceCube.
Working in conjunction with NASA's Fermi X-ray telescope, IceCube was able to link the cosmic neutrino it observed with that outburst from the gamma-ray blazar. The first time such a causal link between neutrinos and a single extragalactic object had been established.
The enormous increase in gamma-ray flux seen by LAT and radio flux by other Tanami telescopes let us finger the exact blazar which is responsible for Big Bird. This is the first time that we can point and say that blazar is where this neutrino came from.
Neutrinos and gamma rays are what Fermi is all about. It has already made some startling discoveries. One of its latest is finding the most distant and oldest blazars. Blazars are a type of galaxy whose intense gamma-ray emissions are powered by supersized black holes. These distant objects emitted their light when the universe was 1.4 billion years old, or just 10% of its present age. That they developed so early in cosmic history challenges current ideas of how supermassive black holes form and grow. Fermi has received an upgrade to improve its capabilities.
We see gamma rays, which are the highest energy form of light. And with each object that we see these gamma rays from, what we're doing is exploring some of the places in the universe with the most extreme environments.
The kinds of objects that we can study are pulsars and neutron stars, black holes, as well as dark matter.
So, to analyze these events, we have written a very long and complex program that basically uses all the information that was recorded by the instrument and figure out what is the direction of the gamma ray, its energy, and whether or not it's a real gamma ray and not a charged cosmic ray. So obviously software is really important for the LAT.
The software that we use to analyze the LAT data has gone through many revisions over the course of the mission. But PES 8 is really the first revision of the software where we took into account all of the experience that we gained from operating the LAT in its orbital environment.
PES 8 has made everything better, but one of the things that it's made better is that it's allowed us to open our gamma ray eyes to higher energies before, so that's a completely new view, and it's allowed us to open our gamma ray eyes at energies lower than before, so that's another completely new view, in addition to improving everything across the entire energy range.
The improvements that we've made to the software retroactively apply to all the data that we've collected. And so these improvements significantly enhance what we can do with the data that we already have, as well as the data that we'll collect in the future.